And I think it's a great presentation from Dave about how to utilize the thickness research suite for from data to insights. And I will be talking about, from the user perspective, what's the benefit of using singular ELN and how it's benefit from the life science labs and users. So, a quick introduction of myself. My name is Yi-san. Good morning, everyone. And it is my pleasure to be here to present enhancing the collaboration and the data management for Merck Life Science with Multi Life Science Labs with ELN. Before I start, a quick question. How many of you are scientists or have been a scientist? A lot. Primarily you are scientists. And how many of you are from IT? Quite a few. So, I'm from IT and supporting life science R&D applications and digital transformation. I do have experience in supporting the life science R&D, and I have been working in R&D labs supporting the next generation sequence analysis. So great, we have overlap on these two areas. From today's presentation, I will show you a few case studies of the benefit of life science using the signals. I think you will be interested to see a great example of how integrated signals with a voice recognition assistant system, which you will be achieved the hands-free the note, and do not need to type anything. Just use hands-free note and connect with signals. It's all integrated with automation. In today's fast-paced and dynamic world, the collaboration and data management are critical for the success of life science labs. Merck, in a couple years ago, Merck Life Science Labs has been faced challenges in these areas, such as lack of the data standardization, data duplication, lack of the data communication, and collaboration. So this has been led to a lack of, for example, the delay of the research, the errors, and increase the costs. Fortunately, Merck has found a solution to solve these problems, which is electronic lab notebook. So ELN is a powerful tool to enable scientists to collaborate seamlessly, to manage the data efficiently, effectively, and to streamline the workflow. Before we take a closer look at how the electronic lab notebook are addressing these challenges, let's watch a short video that demonstrates the manual notebook recording process. And I think most of you are, or all of you are familiar with the contents and the steps. And this video will demonstrate a real-life scenario of how a lab scientist manages the experiment and the data recording in the paper notebook. So in this video, it outlines a general process. For example, the data, the experiment design, experiment planning, and the recording procedures, data collections during experiments, and calculation and analysis, as well as the data review and verification before finalizing the experimental records.
A laboratory notebook is a record of the experimental work done in the lab. It is a legally valid record that preserves the details of experiments and provides a reliable reference for writing up materials and methods and results for a study. Before starting an experiment, write down the objective of the experiment, procedure plan, raw materials and instruments to be used in the notebook. During the experiment, write down a clear record of the experiment procedure, including detailed steps, measurements, and any controls or variables used. This would also ensure replication of same experiment with accuracy later, if required. Record all data collected, which would include observations, measurements, results from the experiment, photos, and diagrams if possible. Perform calculations and analysis directly in the notebook for results interpretation and record the findings in Notebook. Review the data and verify the record before finalizing the experiment record. And that's how lab records are manually maintained in Notebook.
I'm sure you all know what this is. I borrowed this paper notebook from R&D lab in SAXC by processing in life science. So from here you can see it's quite a neat, organized, and clean notebook. So from this notebook you can see that it's full of the data records, data logs, experiment data, as well as the graphs and analytics from the instrument, and scientists just print out from printer and stick out here. Quite intensive and a lot of information over here, right? So a lot of information. So although this paper notebook provides a traditional way of recording experiment and the data points, it has a few limitations. Can someone speak out any limitation by using paper notebooks?
Gotta be searching.
That's a good point. And
There's such a thing, paper notebook.
it's a good okay.
I need the data for a big perspective analysis.
Exactly. So I think you all got the point. How much effort do we need to keep a paper notebook, right? How about we need to perform additional analysis and even sharing the data to the different labs in different locations? So the limitation of using paper notebook include the risks of data loss, the challenges for data sharing, and the difficulty for searching and retrieving information from the notebook. So even we talk about security, right? How to define different permissions from different group of users to access this notebook. There are a lot of such, like many such kind of limitations. So electronic lab notebook aims to address these challenges. Through the ELN, it provides a variety of the benefits, and that enhancing the data management and the collection in labs. So the first benefit that the ELN provides is it has enabled to improve the collaboration across teams and the departments. So it provides a centralized platform, share the data and insights real time and seamlessly, and fostering the culture of the collaboration. Second benefit of the ELN provider is it provides the real-time access to data. So this is a significant aspect for making informed decision and accelerating the research with a faster pace. So there is no more need to wait for the paper data points. All the information is at your fingertips when you need it most. So the third benefit is it reduces the errors and duplications. But through the automatic data entry, the signal notebook can provide the accuracy and the single source of the truth. So we can say bye to the transcription errors and hello to the reliable data integrity. Fourth benefit is close to the speaker. So the fourth benefit is it streamlines the workflow by providing the customized templates. So scientists can tailor the data to the notebook to fit all the specific needs, saving time, and ensure the consistency. Last but not least, the benefit is it significantly boosts the efficiency and the productivity. So by reducing many tasks, they can spend more time focused on the research, which is truly matters ELN. So through the ELN, it empowers scientists to do more and faster. In summary, electronic lab notebooks are not just a tool. They are the catalyst for innovation, collaboration, and progressing in the real world of science. With all the benefit the ELN provides, Merck Life Science had rolled out the usage of the signals across a variety of labs globally about two years ago. Here is a record of demonstrating how the benefits of life science users using the signal ELN. And I think you will be very interested to see a couple of these inspiring user testimony. This video records of what has been benefit of the users, what the result from there, and as well as a lesson learned and the future plan.
My name is Vince Balassi. I am an R&D scientist doing cell line development and engineering in our bioprocessing upstream R&D team. I am located in St. Louis, Missouri at our Laclede facility. I have been using Signals ELN since April of 2021, and prior to that, all of my experiments were notebooked in a physical lab notebook, that's the black paper notebook. Switching over to Signals ELN has saved us quite a bit of time when it comes to notebooking our experiments. However, the most impactful benefit of using Signals ELN is that as we perform experiments, that data is generated, captured, and organized in real time into the ELN. So this allows for higher quality data management and better notebooking habits, as well as gives us in-depth real-time feedback on our experiments by our managers and other reviewers. This real-time feedback helps us make better project decisions and brings more visibility to the work we're doing to the rest of the R&D organization.
I have been using the Signal ELN for more than a year. Before that, I used other ELNs and paper lab notebook. Compared to other ELNs and paper lab notebook, the Signal ELN is more user-friendly. It's easier to create new experiments, searching for old experiments, and accessing the historical data. The Signal ELNs offer a more organized way of creating project and type of experiment. Also, the review and approval process is more straightforward because the Signal ELN is integrated with different Microsoft Office applications. It saved me at least 1 hour a day in data transferring and processing raw data. So far, the Signal ELN is working well for me, so I don't have much interaction with the IT team regarding the technical issues.
So the benefit shared in the video, I'm sure there will be benefit for you as well. Considering that a scientist can save about 3 to 4 hours a week in average, and in a year, so it can save up to like 200 hours a year. So this is a huge saving efficiency. From financial perspective, it is about saving like 20,000 euros per year for a scientist. Although it does not really convert to be finance equivalent to the finance numbers, scientists can use the time to do more of the research and focus more and creating more innovative and creative projects. So we talked about the background, the challenges and the benefits. Now let's look at how the life science utilization of the signals in labs. And I will start with life science utilized the powerful signals, configuration capability to meet different labs requirement, followed by 3 case studies demonstration. In this case study, it provides a practical insight of how these signals ELN can support to provide a way to like form the way for lab operations and can help your organization to achieve the similar results. So let's look at the usage of the sequencing life science. We have adopted sequence for over 40 plus R&D groups for more than 1,000 of users across 25 locations and 50 labs. So it defined about more than 60 security rules for 250 systems and user groups. So this is a complex and complicated situation due to the setup in life science R&D, and because many different business groups need required and meet different configuration needs to meet their security requirements. So in these cases, like some groups of the business, they need to meet the department-wide security rule. So then we defined different levels of the security from security level perspectives. The first level is public. So public is default configuration to allow everyone in the department can access to read and write each other's experience. And the next level is a little bit more security is restricted. So this allows the users in the department can see each other, can read and not modify or write. So only approved users in the department can write or modify the experiment. The next a little bit high level of the security is confidential. So confidential defined only a subgroup of the lab can access, can read or write the experiment. And there are also situations within a department that there are sub-labs, subgroups, and they need access to those subgroups only. So that's why we have lab only permission is defined, that only those subgroups people can access experiment. And then another level is called department only, which is same like public, but with a restriction of the access to the level of the experiment on a specific value and property. Some other groups of the business, they require access of the experiment within a project only. So no department or lab concept, but only project. So we have the confidential project and the non-confidential project is defined. The confidential project defines that only approved user able to access, read, or write those projects. Anyone outside the project group, if they want to access, they need a special approval. And a non-confidential project is defined that anyone in the project can read and write access. So it's open to everyone.
Are there people who keep their things public?
Within the department. Within the department, we always have this concept of within which group. Yeah. So in summary, in license secrets, the group association, along with global security configuration, is used to implement the mapping of the right R&D group to the specific level of the data in the experiment. With this global configuration mapping, each lab can perform the customized workflow and process based on the specific template. Next, I'm going to talk about the 3 case studies. The first case study is to illustrate how ELN and sample measurement can be employed in a lab experiment. So here the scenario is in a molecular biology research lab. They conduct a series of experiments to study the generic basis for a particular disease. So scientists, the research scientists, they start by outlining the experimental plan and in ELN. So they document the research objective and the experimental design, as well as the specific DNA sequence methodology and the reagents and the instrument they will use. In this case, you will be finding out the right structure setup and template setup in the Sigma ELN. On the left side, you will see exactly the background, the introduction, description, the each sector fit with the needs of the workflow, and the details of the introductions, and then the materials and the materials table defined in the experiment, as well as the bottom right, the results will upload it to the Sigma. So a few key highlights from this. Obviously, the experimental workflow have provided the better visibility. So it has centralized, shared documentation, and able to facilitate the process tracking via flexible workflow. And it has enhanced transparency. They provide seamless and automatic handover from one scientist to another one, and able to provide the searchable, traceable, and auditor functionality. And very important, it has improved the efficiency, reusable templates, and able to have centralized reporting to reduce the time spent in the data search and data cache. So besides the experimental workflow, it is worth to mention that under the broader term of the central management, how would it look like it can support for the day-to-day lab operation. You will see that from left side. So it is an independent module in the Sigma ELN to create a library for sample management. So there's no need to replicate and data in all the experiment. You can create a list of samples up to 1,000, and can record all the parameters and property and information related with the sample, and able to upload the results to the related sample. And from experimental perspective, it's just a reference to the sample ID, and all the information will be injected into the experiment. So the benefit of doing that is it's optimal asset utilization. So Beverly can manage a large number of samples and with contextualized samples, and it can have a better visibility and compliance, eliminate errors, reduce time, and for data integration. And it's a single source of data source, and only need to capture data once, one time. No need to replicate and enhance the collaboration. So, in the second case study, I would like to show to you is integrated links with ELN. I think yesterday, Colin has introduced a very good foundation from Sigma perspective, how the web service is integrated, how the code can be written to the web service integration. Here we exactly leverage this capability to have the integration between ELN and Sigma, ELN and links. So I will show from user perspective the integration process. What is the element for this integration? The first element is for data exchange protocol. So they have to have the agreement between two systems. Such protocol exists. That means API have to be there to be defined. Second element is data mapping. So after agreement, the IT people and the data scientists, they need to agree on what data need to be transferred between these two systems, which is data mapping. Third one is a bidirectional communication. So this is not only from one system to the other, also from the other to the vice versa, the opposite direction. Last but not least, is very important is for user access and authentication. This is very important from security perspective because we do not say that everyone can request any information from another system to this system. But they have to have authorized, authenticated user to push the right information from links, for example, to ER. You will see that this is the needs, what information is your part. So actually we have a use case in the signals that raw material, we need a compliance regulatory safety information. And rather than enter those information manually, and they already available in the LIMS system. So we connect these two systems, make sure that once the scientists require this compliance information, they click a button and data will be transferred automatically, quickly and in real time from LIMS to Signal. So the benefit, of course, is have efficient data transfer, and it's have real-time data availability. So it's streamline the workflow and the scalability when the data set goes to very large scale. So this is a very, I'm so excited want to introduce with you. Life science labs will be is early adopter to integrate Signal with a voice assistant software. There is a scenario in the labs that scientists want to hands-free notes. I know I have lack of time, so I want to just show you and quickly go through that. The left side screenshot of the video, you will see everything is recorded without any typing. So through voice, you can record all the descriptions, the steps, your data results. You also can speak out to the device and turn on the camera and take screenshot and also scan the barcode on the label of the instrument and raw material. Information will be integrated everything from name, from serial number, from the topping, molecular weight, and put it in the notes. Now by clicking the button on the top right, and this note will be transferred to a Signal under a specific experiment seamlessly. This is fantastic experience, and we have just finished the POC last week. The two labs in the PAD, and they have achieved the same scenario using this voice assistant software. The key highlights: hands-free data entry, improved data quality, enhanced data context, and improved efficiency. So conclusion, with all the features that Signal provides, it have the flexible document templates that promote the culture of transparency and enhance the compliance, and automates the data transfer. Of course, it has with the web services capability, it has flexibility to integrate with other systems. Very important. Last but not least, I would like to share this acknowledgement. It's very important to recognize the contribution of the stakeholders and our team members. I recognize stakeholders and as well as Merck IT colleagues and our excellent ELN collaborators. Thanks for your support and throughout this project and current operation. David, Casper, and any other colleagues from the stage. All right, and with that, I concluded the presentation and open for any questions.